Hello and welcome to TelecomTV and TelecomTV's Executive Insight. I'm Martin Warwick. I'm delighted to be able to tell you that I'm talking with Matt Bross, who used to be the CTO at BT, then at Huawei, and then he disappeared off the radar screen for quite a while actually, and now he's back with a company called Compass. Matt, great to see you. You have been away for a while.
Yes.
Now you've returned with Compass. What is it? Tell us about it.
Well, Compass is an Israeli high-tech company that the founder, there's two co-founders, the founder was like the first, if not the first, one of the first employees of Cisco in Israel.
Right.
He is, Michael Lahore is his name, amazing guy. And his co-founder is Michael Mesh, a Russian immigrant to Israel like 27 years ago, a brilliant physicist in optics. And these two guys combined together to found this company, which Compass. I'll love to tell you about what the technology is, but they have brought into existence a new element that across the ICT spectrum, whether it is information, communications, computing, it will impact the ICT industry for the next decade, I am positive.
Okay, now, Matt, this is a new technology. What is it?
The genesis for this invention was the knowledge that as wires ran out of the capacity to carry information over shorter and shorter distances, you needed to replace it with fiber. Well, as Michael Lahore looked at building next scale packet forwarding and routing systems, he realized that the fundamental building block in building a low latency, low power, single stage platform was the amount of I/O into the chip. It was limited by the electrical connections. So the problem they set out to solve was, how do I get more I/O? Now, Martin, for a long time, people have understood it would be really great if I could get light to come out of silicon. But if you put energy into silicon, it's a very poor material to produce light. So what they solved was nothing short of amazing. In this chip, you see there's 168 vertically cavitated lasers and 168 photodetectors. This is a 2.7 terabit per second I/O into a single piece of silicon. So this new building block uses the electrical connections that have always existed, and they continue to advance in their performance, but it couples it with a world's first icPhotonic, integrated circuit photonic connection. And out of this new set of intellectual property and technology, we can transform the communications infrastructure, the computing infrastructure, the storage infrastructure. Compass itself is very focused on the growth of SDN and how to enable and accelerate that growth. We're very focused on the data center, how to change the architectures in the data centers such that we can take megawatts out of the power that it requires to build the infrastructures. And we're looking further down the road at how computing architectures, memories, and storages can be changed once you can go in and out of silicon with light in addition to the electrical interconnects. So Compass has brought to market a fundamental new piece of technology and has put it into a platform, Martin, that we call an SDN Forwarding Plane, an open and programmable SDN Forwarding Plane.
How does this then play into the whole concept of Moore's Law?
Well, so Moore's Law, in terms of the doubling of the devices every 18 months, has to do with the silicon. So 2, 4, 8 billion devices on a piece of silicon is the embodiment of Moore's Law. What we witness is that the electrical interface to that ever so denser piece of computing has not advanced at nearly the same speed. So consequently, if I go into a computer chip using wires, the most state-of-the-art wires on Earth, It operates at 25 gig. That uses 1 millimeter of the silicon per 5 gigabits, okay?
Yep.
With icPhotonics, I can drive 62 billion bits per second per millimeter squared. So what it does is it unlocks the power of the Moore's law progression by being able to go in and out of silicon 12 times more efficiently and with 1/5 the power per bit. So while it isn't a progression of the number of devices on a piece of silicon, it is like opening up that piece of silicon so that information can flow in and out in a more frictionless way.
Matt, over the past couple of years, there's been a sudden emphasis on SDN and NFV. What about Compass? You're aware of that. You have something you mentioned just now called the SDN Forwarding Plane. What is it?
So what the SDN Forwarding Plane is a new network element. It has its DNA, its lineage from the routers of yesterday, okay? So therefore, it can connect with the legacy infrastructures with the native protocols. But the difference is that the northbound interface of this SDN forwarding plane is open and programmable, and it looks to the policy engines, it looks to the SDN controllers to tell it what to do, take the business rules and the business processes that are formulated in the SDN at cycle times that match customer expectations, and it tells the forwarding plane what to do with each and every packet that's flowing into it. So now what you have is a very simple, reliable, low cost, low power transition for operators around the world from the legacy infrastructure to the SDN infrastructure. And our SDN forwarding plane sits beautifully in that space.
Until very recently, SDN was based in and around data centers. That's no longer the case. It's moving out into the carrier space, into the service providers around the world. You're aware of that. You're driving some of that, I assume. Do you actually think this could mean the end of the router?
So routing technology will be around because it is the vascular system between the world's people, okay? And so will they look exactly the same as they do today? Not likely, okay? But I don't call the end of routing, and frankly, like many people who will, they've never operated big infrastructures. I have the capital depreciation schedules I need to look at. I have the fact that these things will provide tremendous value for a long time to come. But operators, and more importantly, the customers of those operators, want new services in software cycle times as opposed to infrastructure cycle times. And so we are building a network element that enables that migration to the future faster. And something I like a lot is it puts the control back into the CIO's hand, back into the CTO's hand.
Now, Matt, SDN and NFV are predicated almost completely on the notion of being open standards across the board. That's what the carriers, it's what the service providers want. They don't want to be locked into a single vendor again, and they're kicking up against it. Do you embrace that notion at Compass, that open standards are good?
Martin, in our discussions over the years, I spoke to you about the notion of open innovation.
Yes, you did.
I've spoke to you many times about the need for companies to unleash innovation beyond the boundaries of their payroll, okay? This phenomenon is simply what people are demanding now. SDN means that within their organizations or in a collaborative way with developers outside of their payroll, new things can be invented, they can run on their infrastructure, and the operator's cash register rings when they're successful, okay? This is a good thing. So you might imagine, this has been my view for many years. And we now sit with the industry moving to a position where it's a reality. And so the the very nature of the Compass SDN Forwarding Plane is an open, programmable, northbound interface that we call it AnyFlow. Because I believe that in the carrier and data center operator environments around the world, you will have a near infinite combination of the softwares that exist. You may have multiple SDN controllers from different divisions or different departments that try to tell the forwarding plane what to do. We will be open and programmable to all of those. And I think that's an essential element to accelerate the migration for operators to this new infrastructure and give them the ability to move in software cycle times, not infrastructure, and to open the innovation beyond the boundaries of their payroll.
So Matt, it's a new technology, it's a new network element, sounds fascinating, but A, does it work? And B, can you prove it? Have you got any deployments anywhere around you can tell us about?
Well, we just announced last week with Jersey Telecom's CEO Graham, lighting up the link between Jersey and Guernsey. And here at the hotel, there's a financial conference where the economic development of both Jersey and Guernsey were, and I was actually with them right prior to talking to you. Some delightful people, by the way. And they're selling hard on their advantages. But we, inside of our machine, have a couple of attributes that are very, very desirable in today's cyber challenged space. We have many trials and are working on even much more significant commercial deals. But for the specific names, Martin, I'm going to let the customers, as I would have always expected at BT,
Sure.
to get to say when and where that's announced. I will tell you that we are in production operation terminating undersea cables for a tier 1 customer. We are operating in content distribution network and peering for tier 1 customers that are up and live and running real traffic on the SDN forwarding plane today.
Matt Bross, great to see you again. It has been a long time. Don't leave it so long next time. Thank you.
My pleasure.